Hi friends, in this video we are going to discuss one important problem. So here this problem says find the point on the surface z square equal to xy plus 1 nearest to origin. So here let's say find the point. I want to find the point P, let's say with coordinate x comma y comma z. So we are in three-dimensional space. So I want to find the point P with coordinate x comma y comma z, which is distance from origin. Here let's say origin 0 comma 0 comma 0. My objective function is to find the P which distance from origin is minimum with respect to this surface z square equal to xy plus 1. So here my objective function is to minimize this distance d. Here my objective function, I want to my objective function is to find this distance between this point P to origin which is minimum. So here my objective function, so my objective, that is my objective function equal to my objective is to find the minimum distance between that point to the origin. So here my objective function is to find d, that is distance from that point P to origin, which is minimum of minimum. Let's say distance between this point to origin is here. Let's say P is the point with coordinate x, y, z and O is the origin with coordinate 0, 0, 0. Therefore distance between P to O is here x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square. So here which is equal to under root here x square plus y square plus z square. So therefore d equal to this. So d square equal to, I want to use partial differentiation method. So here this is d, instead of that I will take square root, squaring on both sides, x square plus y square plus z square. So here this is my objective function. I want to find the coordinates of P are x, y, z such that this distance is minimum. So here this distance is minimum. So this is my objective and try to so this is my objective with respect to the constraint. So my objective have some bound. So here with respect to this constraint, so here my constraint is surface z equal to xy plus 1. So here constraint is, so over the surface z square equal to xy plus 1. I am unable to choose any point xyz such that this nearest distance from the origin is minimum. So here I want to choose the point from which satisfy this equation of my surface z square equal to xy plus 1. So here how to find is the following. Now I want to find the coordinates. So here coordinate first x, y, z such that distance between that xy point P to origin is minimum here. So this is my objective function. I want to find d minimum. So here how to find is the following. Now here just consider let P of x comma y comma z be any point on surface z square equal to xy plus 1. Let xyz be the any point on the surface z square equal to xy plus 1. This is my surface. So let P of xyz be the point on the surface, let's say with minimum distance from origin. So here from origin O 0 comma 0 comma 0 is. So here let P of xyz be the point on the surface with minimum distance from the origin is, let's say, now tell me the distance from origin. So with coordinates, so tell me the distance between 2 points. Here x minus 0 square is d. So here d equal to x minus 0 square plus y minus 0 square plus z minus 0 square. Therefore here d equal to this, therefore d equal to under root here x square plus y square plus z square. So this is my objective function. I want to find the coordinate x, y, z such that this distance is minimum. So here I am using the maximum minimum concept. So for that purpose, I want to you find the partial derivative of xyz with respect to x. So here if I keep d equal to this, so here while finding the partial derivative, so partial differentiation is somewhat difficult. So instead of that, I will do one thing. So let's say d square equal to, so here d square squaring on both sides. This is same as x square plus y square plus z square. So here d equal to square root x square plus y square plus z square is same as d square equal to this. Now, so my surface equal to z square equal to xy plus 1. So here I want to convert. This is my function d square equal to x square plus y square plus z square is my function in 3 variable. But here these 3 variable are tied up with some condition, with some relation. With that relation is z square equal to xy plus 1. That is my constraint. So here this is my function. Here this is my function with constraint z square equal to x y plus 1. Now I want to convert my here function d square equal to this x square plus y square plus z square into function of 2 variable by using this constraint. So here therefore f of x comma y, let's say f of x comma y equal to here f of x comma y equal to x square plus y square plus, in place of z square here I am putting xy plus 1, because this point P is on the surface, so that point must satisfy the equation of surface. Therefore this constraint satisfy this equation. Therefore f of x comma y, which is equal to, let's say d square equal to f of x comma y, which is equal to x square plus y square plus xy plus 1. So this is my function. Now I want to discuss maxima and minimum of this function. I want to discuss the extreme value of this function. Let's say f of x comma. So for that purpose we have to find dou f by dou x equal to 0 and dou f by dou y equal to 0. Therefore here d square, instead of d square here I am writing f of x comma y. Therefore solve dou f by dou x equal to 0 and dou f by dou y equal to 0. I want to find the stationary point of my function. Therefore here dou f by dou x equal to, here this is 2x plus y, which is equal to 0. Now again dou f by dou y equal to 0 equal to, so here this is 2y plus x, which is equal to 0. Let's say this is my equation. Let's say this is my a and this is my b. Now from a and b, so here solve a and b. So that is 2x plus y equal to 0 and 2y plus x equal to 0. So here multiply equation, here this is my a and this is my b. So here multiply equation b by 2. So here I want to solve this 2. I want to find the value of x and y. So here just do one thing, multiply equation b by 2 and subtract from a. So here, that is here I will write here from b here 2x I am multiplying plus 4y equal to 0, and this is from a. So here subtract equation. So this, let's say this is my c. Let's say this is my c. So subtract equation c from a. Therefore here subtract c here from a. This implies here 2x gets 0. This is y minus, so this is minus 3y, which is equal to 0. This implies y equal to 0. If y equal to 0, just put the value of y equal to 0 in this equation. Therefore here x 2 times x equal to 0. 2 times x equal to 0. This implies x equal to 0. Therefore the critical points are 0 comma 0. So here I don't want to write this. So instead of that, here I will write. So here solving a and b, here solve a and b, we get x equal to 0 and y equal to 0. Therefore x comma y, which is equal to 0 comma 0, is a stationary point. Now here I got the stationary point. Now I want to find here R, S, T. I want to check the nature of my function at this stationary point. Now here find R equal to dou 2f by dou x square and s equal to dou to f by dou x dou y and t equal to dou to f by dou y square. Now tell me dou to f by dou x square. This is my dou f by dou x. Here this is my dou f by dou x. Therefore r equal to dou to f by dou x square. Partial derivative of this function again with respect to x. So this is simply which is equal to 2. Now I want to find s. So here s equal to dou to f by dou x and dou y. So this is dou f by dou x. Again I want to partially differentiate this equation with respect to y. So this is 0 and this is 1, which is equal to here 1. Now t equal to dou to f by dou y square, which is equal to. Now tell me. So partial differentiation of this function again with respect to y. This becomes simple 2. Therefore here r is constant, s is constant, t is constant. So here at 0, 0 is also r s value are same. Therefore add let's say at critical point of 0, 0, here r equal to 2, s equal to 1 and t equal to 2 same. Therefore r t minus s square equal to here 2 minus 1 square, which is equal to 4 minus 1, which is equal to 3, which is greater than 0, and r equal to 2, which is strictly greater than 0. Therefore your function, that is your function f of x comma y, has minima at 0, 0. Therefore f of x comma y, which is equal to d square, has minima at point 0, 0. So this is the point where my distance, where my d equal to d square is same as d is minimum. So here this is the point where my function has minima. Here if x and y with 0, 0, my d square has minima. Now I want to find my third coordinate. So here this is the point. So here where at which my function f of x comma y is minimum. With minimum value I will find later. But now first now I want to find third coordinate z. So with the help of this x and y coordinate, because here x comma y belongs to the same surface. So here that satisfies the equation of surface. Therefore here at 0, 0, therefore z square equal to here 0 into 0 plus 1, which is equal to 1. Therefore z square equal to 1. This implies z equal to plus minus 1. So this is my third coordinate. Therefore z equal to plus minus z square equal to 1, z equal to plus minus 1. Therefore d equal to, or we can say d or d square. D is here, d is means distance, distance minimum at here x is here 0, 0, let's say plus minus 1. So this is the coordinates of p x y z such that which is distance from the origin is nearest. Therefore 0, 0, 1 and 0, 0, minus 1 are the points nearest to origin. So this is my answer. Now I want to find distance. So here therefore d equal to so here x square 0 square plus y square 0 square plus either 1 square, here 1 square, which is equal to under root 1, which is equal to 1 with distance d. So here this is my minimum distance. So this is my minimum distance. So here just the point is 0, 0, 1. So here my question says find the point on the surface, that is these are the points 0, 0, 1 and 0, 0, minus 1 are the points on the surface z square equal to xy plus 1, which is nearest to the origin. So with this nearest distance from the origin, so 1. So this is the way to solve this question. So here why I am saying this x, y, z satisfy this equation of surface, you can just put the value of x, y, z in this equation that satisfy this equation of the surface. In this way you can solve this example. So this is the answer. Thank you.